Hi, I'm Preston Dutton, and I'll be talking to you about my Marvel dialogue classification project. So this project is a natural language processing project that builds models which can predict a character's name given a line of dialogue from one of the Marvel movies they appear in. So this project uses a custom data set derived from the Marvel released scripts, and these PDFs are processed with the pandas library into a CSV with columns character and line. And while I would have loved to use all 12 of the Marvel release scripts, I only had time to use about 5 of them. So I used Iron Man, The Avengers, Thor Ragnarok, Guardians of the Galaxy Volume 2, and Avengers Endgame. So this project creates and compares 12 different models, each of which uses a different combination of NLP classifiers and techniques. So the first 4 use naive Bayes classifier, the next 4 use a random forest classifier, and the last 4 use a support vector machine classifier. And for each of these, we decide whether we want to use word stemming and term frequency transformations. So these models were implemented with Scikit-learn, and Scikit-learn provides an interface for grid searching, which is we provide a list of hyperparameters we want to test out, and grid search CV uses cross-validation to test out every combination of these models. So all 12 of these models are grid search models. And we remove stop words from the text before we try and process it. Now, stop words are words like the, I, we, and she, stuff like that, that don't provide much value to any classifier. So it's been shown you can improve accuracy by removing these words. Word stemming, as I mentioned above, is where you take a derived word like fishing or hiking and you transform it back into its base word like fish or hike. And this has also been shown to improve accuracy. Term frequency transformations is where these models work by counting the number of words in a document. In our case, these documents are lines that a character will speak. And term frequency essentially normalizes the count of each words by analyzing across documents. So in these cells, you can see we import scikit-learn and our data set. And here you'll see we do some analysis on line counts per character and words per line. And you can see most characters actually don't speak that many lines, and some characters speak a ton of lines. So to solve this, in pre-processing, we restrict our data set to characters who only speak more than 150 lines. And for this project, that's Tony Stark, Thor, Steve Rogers, the usual cast you'd expect from all of these movies. So here you can see we define our models that we'll be using and the parameters we want grid search to use. And here we just go through and we train all 12 of them. And this took a long time, and because some of the training times were too extensive, models number 8 and number 12 did not perform a full grid search. They instead used parameters taken from similar models to help reduce that training time. So you can see here we report the cross-validation scores. We're reporting balanced accuracy for all 12 of our models. We report it for 5 folds with a mean and standard deviation. And our best model was model number 4, which is a naive Bayes classifier that uses term frequencies and word stemming. And this only reported a max balanced accuracy of 29.8%. And I'll explain why I think that is in a second. Compared to a majority classifier and just random guessing, Model 4 actually does perform at least twice as well. So we know Model 4 is making some intelligent decisions. If we plot a confusion matrix, we can see that our diagonal elements are present, which means we are having some correct classifications. And you can notice a general gradient of lighter colors to darker colors up in this corner. And if you write that next to the number of examples each character is trained on, you can see the characters with more examples are more likely to be predicted, and yeah, more likely to be predicted. So this was one indication that we need more data to train. And I also plotted some learning curves, which plot our scores as a function of the number of examples. So you can see as the number of examples increases, our training accuracy, our testing accuracy is increasing. So it's reasonable to assume that if we include more data, this trend will continue, and we could see great increases with accuracy. Now, what I took away from this project was a lot of stuff. This was my first experience with NLP, so it was very exciting to learn about all these different things and techniques. And if I had more time on this project, I would obviously process more movies, but I would also explore different types of techniques like word to vector and neural networks. So in general, I had a lot of fun, and I'd love to keep working on this. Thanks for watching.